Hello everyone, welcome back to my channel, Day One Dev, and thank you for subscribing the channel also. So today we're going to talk about content delivery network. So let's start with that. CDN involves leveraging a distributed network of an edge servers to store and deliver content closer to end users, significantly reduce the latency. Edge servers caching or a CDN content delivery. Edge servers caches a static website, content, images, JavaScript, CSS, and HTML files, static HTML files, to facilitate a quicker content delivery and minimize the server load. So nowadays, also there's a videos has been cached to an edge servers. The CDN facilitates a global distribution of a content strategically placing edge servers in various regions to serve content from nearest server to the user location. So these techniques are employed to efficiently handle dynamic content, ensuring its seamless delivery through the CDN architecture. We'll talk about that in the next slide. Integration with the DNS for effective traffic routing, utilizing a DNS-based load balancing and any cast routing for optimal content delivery. CDN is also a global distributed network for servers that cache and deliver content closer to end user, optimizing performance, availability, and security. So let's talk about some of our functionalities of a CDN, which already we discussed in one of our product page, but still I summarize a few quick things here. CDN stores copies of static content on its servers located in different geographic regions. When a user requests a content, the CDN directs the request to the nearest edge server, reducing latency and load of origin server. The edge server retrieves the request content from its cache, or it's not cache, fetches from the origin server and deliver it to the user. So what I explained, let's go and see it in an architecture diagram here. So as a user, you're here and you hit an, let's take an day one dev website, and that the origin servers are somewhere in US, but the requests are coming from Asia or Europe. If the connection going through DNS to origin server, the latency is added. So the cache can be done with the CDN. The CDN delivers faster content. If the data is cached here, or if the data is not cached, it calls the origin server, caches the data, and delivers. So whenever if generally that is not a best practice, whenever a new content has been there, the origin servers, as part of their production release, they invalidate their old content and they cache the new content. So they'll do it in kind of as part of their production release process. Once they do it, there will be no latency for the customer. But I've seen few projects, low activity projects, they never invalidate their CDN data, but they wait for a first customer to hit their CDN, and it will go to origin, it caches the data. That was a statement which I called out when we were talking about in the last previous slide. Okay. In this architecture, always breaks down a CDN solution. So let's take a simple example. I think most of you guys have used Netflix, which is a video streaming platform. So they record content, they upload it to one of the cloud provider. They are origin servers, and the content might be in one or two regions, right? So now they have a CDNs all over the world because they serve a content in multiple languages, multiple countries. So this, if the content has been pulled from only the certain region, if the servers are in US, the customers are in Europe and Asia, or Africa continent, they expect a lot of latency and buffering, right? So to avoid that kind of a stuff, there's always a CDN. The content is cached to nearest location for the customers, and the content is delivered pretty quick. So that is where it's going to help you a CDN. But the DNS can be done based on low latency, where the faster access to certain people, certain region, are based on their bandwidth of a network. And also, the DNS can be routed based on their localization preferences. The content can be localized preferences. So, for example, if your content has been built on English stuff, the CDN part where you might have done a translation, you put it in a static place, and that can be CDN can be cached. Certain CDNs can be cached only to support certain languages. For example, the DNS can be routed from here. So let's take an example here. If you are in China, you're coming from your request is in China. If you hit some website.com, the request is from China, then it can automatically route CDN of the Chinese version of our content. Or if you are on targeted to a French, then you might have the DNS can be routed to a French version of a CDN content. Or some reason if your entire content is only in English supported, then you might be serving all your CDNs are English content, but you are serving your nearest region CDN. So that's where it helps. So now let's call out some of our performance related where the page can be faster, load times will be reduce the latency. It's technically closer to your proximity of a users. And it improves the responsiveness, which is and reduce the buffering of your streaming media, which I called out as part of your Netflix example. And handles a large traffic spikes and distributed denial attack. So there's another part if you are using a cloud provider or the products which I shared in my previous video about content delivery network providers. Some of our cloud providers right now, they support DDoS attacks as well as web application firewalls. So you get a lot of free basic stuff comes with a free of cost if you're using the CDNs. But if you need advanced DDoS attacks or WAF, still you can purchase from the cloud providers. That's one of our good towards moving to a cloud. Right? And keeping all this aside, there's also, I suggest that the CDN has certain specifications, which I highly recommend more. You should be aware of that specifications that will help you to, when you're picking your CDN, always that helps you. So let's go to our references here. So the Open Cache Protocol is a standard for interacting with CDNs and defining a request and responses mechanism and caching a control. EdSide includes, which is ESI. It's a markup language for assembling the web pages from fragments cached on a CDN edge servers, enabling a dynamic content delivery. As you know, HTTP 2 and HTTP 3 are newer version of HTTP protocols, and all the CDN supporting features like a server push and multiplexing, improving the CDN performances. All right. Thank you for watching this video, and I hope you're going to subscribe to my channel, and I'll see you in the next video. Talk to you guys later. Bye.